Welcome back to the Formulation Classroom. In today's episode, we will cover factors affecting solubility. The structure of a compound significantly influences its solubility. Different types of chemical bonds, the functional groups, and molecular arrangements can affect how well a substance dissolves in a solvent. Let's start with the polarity. The rule of thumb here is like dissolves like. Polar compounds tend to dissolve in polar solvents because the positively and negatively charged regions can interact with the partial charges of the polar solvents through dipole-dipole interactions or hydrogen bonding. Similarly, nonpolar compounds dissolve better in nonpolar solvents as they lack these polar regions and thus interact better with other nonpolar molecules through London dispersion forces. Now, let's consider hydrogen bonding. It is a powerful force that can increase the solubility of compounds in water. For example, molecules with hydroxyl or amino groups form hydrogen bonds with water, enhancing their solubility. Next up are ionic compounds. These compounds, like salts, break into ions in a solvent, and their solubility hinges on the strength of ion dipole interactions. The solubility generally increases with the charge and decreases with the size of the ions. But there's more to the story. The size and shape of molecules play a crucial role in solubility. Larger molecules, or those with complex structures, may struggle to fit in to the solvent structure, leading to decreased solubility. In a similar fashion, the molecule's shape can impact how well it interacts with the solvent. Functional groups within molecules also dictate solubility. Polar groups like hydroxyl and amino increase solubility through hydrogen bonding, while nonpolar groups such as alkyl chains tend to decrease it. Another intriguing aspect is steric hindrance. Bulky groups can obstruct the molecule's interaction with the solvent, reducing their solubility, especially if they impede the formation of favorable interactions. The pK of a compound also affects its solubility. This is because it influences ionization behavior, and ionized molecules tend to be more soluble due to their enhanced ability to form ionic or hydrogen bonds with the solvent. Temperature plays a vital role as well. Generally, solubility increases with temperature, which can be crucial for the dissolution and absorption of the drugs and pharmaceutical formulations. Particle size is another key factor. Fine particles have higher solubility due to their larger surface area, which facilitates quicker and more efficient dissolution. Lastly, we delve into polymorphism, where different crystal forms of the same compound exhibit varied solubility profiles. This is due to the differences in the crystal structure, the surface properties, and interaction with the solvent. In conclusion, understanding the factors that affect solubility is essential for optimizing the drug formulation and ensuring effective drug delivery. Join us next time as we explore the factors affecting permeability, another cornerstone of pharmaceutical sciences.